We are now in 2.8 day 2, and you're going to find that a lot of the things in this section look very similar to yesterday in day 1, with only a couple of small differences. Yesterday involved just all polynomials that were no fractions involved, but as you know, this unit we've been dealing a lot with fractions, and that's going to be in the mix here today. Because fractions are in the mix, one thing that's going to be added is undefined. It's possible that a function can be undefined at a certain area on the graph, and we'll be taking a look at that. This is based on, mostly vertical asymptotes, but we'll see some other things that affect that as well. So what we need to do is very similar to yesterday. We are going to, again, find some zeros, but you'll notice now we have top and a bottom. We're going to treat all of these for the time being as just regular zeros, and then adapt that from our number line. So, for instance, x plus 5, negative 5 would be a 0 for that one. 2x plus 1, if we were to set that equal to 0, solve for x, we'd get negative 1/2 as the 0 from that one, and then the 0 from this one would be 1. So we are going to, just like last time, set up a number line. This is going to be the work that we show for this one. And we're going to use all of these as zeros. We're just going to put them in a line from left to right. Again, just sort of keep them spaced out evenly so we can write stuff in between. So we have negative 5, negative 1/2, and positive 1. That'll separate our number line into a few different chunks. Now, the thing that I want to point out today that's kind of important is these two on the bottom. We made those 0, and whenever you make the denominator of a fraction 0, it's undefined. So what I'm going to do on the number line, just to make sure I remind myself, is I'm going to mark this as undefined and this as undefined, because they're not zeros actually, they're undefined points, and it'll represent vertical asymptotes on the graph. So now we go through and we make our sign chart as we did before, using our test points, and we choose the nicest test point that we can think of. Now, one other thing about this is that we should set it up in a fraction form so that the way we do these things look like what you see up on top. They look like these three different factors. So start with the easiest one. 0 is always the easiest. I like 0. So somewhere in here we'll choose 0 as a test point. If you plug in 0, that makes the top positive. It makes this one 2 times 0 plus 1, that's positive. And then 0 minus 1 is negative. So if we've got one negative in the mix, that makes the whole thing here, that makes this interval negative. All right, we keep going with that. Maybe we choose positive 2 over on this side. So 2 plus 5, that's positive. It'll stay positive up on top. 2 times 2 plus 1 is positive. And then 2 minus 1 is also positive, and so that interval will be overall positive. Okay, maybe work our way backwards now. For this interval, a test point that we could choose, probably the easiest one, would be negative 1. So if we did negative 1 plus 5 on top, that's going to be positive. Negative 2, or negative 1 times 2, so that's negative 2 plus 1, that'll be negative. And then negative 2, or negative 1 minus 1 is negative 2, so that's also negative. Two negatives equal a positive. So then that interval is also positive. Now this last one's going to be a little bit different. This last one, we get negative 6 maybe as a test point. Here's where I run into some trouble. I have negative 6 plus 5, that's the square root of negative 1, so that actually ends up being imaginary on the top. That's going to be square root of negative 1, that's not a real number. On the bottom, they end up both being negative, but it doesn't really matter anymore because the top was imaginary. And so it's pretty much the same thing as just saying undefined. So we're going to label that particular interval as undefined. And now we're going to use this information and see if we can state the positive, negative, 0, and undefined points in this whole thing. Well, The graph here, also you'll notice on the side, it'll just serve to confirm what we're looking at here. So we want to know, maybe we just want to know the zeros first of all. The zeros, when I look at this number line, the only one I see is -5. And so we'll put that in there. That's the only point that's 0, and that's actually on the graph. It's hard to see on this graph, but it actually comes to a stopping point there and doesn't go any further. Undefined values. Well, we have a couple of places for that. We know that these two individual points are undefined, -1/2 and 1. But then we also know that this whole interval is undefined. So we're going to go -∞ to -5. And I'm going to use a rounded bracket in this case because if I get to -5, that's actually a 0. So that wouldn't be included in that undefined portion. So we'll leave that one as it is. Next is positive and negative, and for these we just have between a couple of numbers there, 1 to infinity there. We are going to use all rounded brackets just because we're not using the zeros or the undefined values. So that means that we'll have -5 to -1/2 with 1 to infinity. Those are positive ones. Last interval is a negative. The negative interval goes from -1/2 to -1/2 to +1. Again, we're going to use rounded brackets here because the points around it don't count, at least in this case. When we have inequalities like greater than, equal to 0, less than or equal to 0, then we'll start using square brackets. But for now, we're just charting out all the different possible values in this example.